I bet you didn't know the ground beneath your feet is actually moving through a universe that's getting bigger every second. The truth? Our cosmic address is changing, right now. Imagine you're holding a balloon. You draw little dots all over its surface, each one representing a galaxy. Now start blowing air into it. Watch as the dots move away from each other, not because they are crawling across the balloon's skin, but because the balloon itself, the very fabric of space, is getting bigger. This is happening right now, all around you, on a scale so vast it's hard to comprehend. The universe is expanding. Every galaxy is moving away from every other galaxy. It's a cosmic dance where the dance floor itself is growing, pushing all the dancers farther apart. Our own Milky Way is part of this grand, silent explosion that has been unfolding for billions of years. This wasn't always a known fact. For most of human history, we looked up at the night sky and saw a fixed, unchanging celestial sphere. The stars seemed like permanent fixtures in the heavens, a reliable backdrop to our lives. But in the 1920s, an astronomer named Edwin Hubble changed everything. He was using one of the world's most powerful telescopes at the Mount Wilson Observatory in California. He wasn't just looking at stars, he was looking at entire galaxies, faint smudges of light that were once thought to be simple gas clouds within our own Milky Way. He wanted to measure their distance and their speed, a monumental task for his time. Hubble made a startling discovery. He found that almost every galaxy he observed was moving away from us, and the farther away a galaxy was, the faster it was speeding away. This was a bombshell. The only way this could be possible is if the entire universe was expanding. It was like realizing that the solid ground beneath your feet was actually the surface of a rapidly growing sphere. This idea, known as Hubble's law, shattered the old notion of a static, eternal universe. It painted a new picture of a dynamic, evolving cosmos, one with a history and a future. So what does this mean for us here on our little blue planet? It means that our cosmic neighborhood is constantly changing. The light we see from the most distant galaxies has traveled for billions of years to reach our eyes, and in that time, those galaxies have moved even farther away. We are seeing them as they were in the distant past, like cosmic ghosts. The universe is not a quiet, still place. It is a place of incredible energy and motion, a single, coordinated expansion that began long before Earth was even formed. Our place in the cosmos isn't fixed, it's part of an incredible, ongoing story of growth. If everything is moving apart, it leads to a logical question. What happens if we rewind the clock? If you play the movie of the universe in reverse, all those galaxies rushing away from each other would come rushing back together. The expanding balloon would shrink. Every galaxy, every star, every atom would converge into a single, incredibly dense and hot point. This isn't just a wild guess. It's the foundation of the Big Bang Theory. It tells us that our universe had a beginning. It suggests that everything we see and know burst forth from a state of unimaginable energy. It was the starting gun for time and space as we know them. This idea of a beginning was so radical that it took decades for scientists to fully accept it. But the evidence kept piling up. In the 1960s, two radio astronomers, Arno Penzias and Robert Wilson, stumbled upon the most important clue. They were trying to use a large radio antenna for satellite communication, but they kept detecting a persistent, faint background noise, like a hiss, coming from every direction in the sky. No matter where they pointed their antenna, the hiss was there. They tried everything to get rid of it, even cleaning out pigeon droppings from the equipment, but the noise remained. What they had found was not noise at all. It was the afterglow of the Big Bang itself. This faint radiation, called the cosmic microwave background, is the leftover heat from the creation of the universe. It's an echo of that primordial fireball, now cooled and stretched by 13.8 billion years of cosmic expansion. Finding it was like finding the warm embers of a fire that was set eons ago. It was proof that the universe was once much hotter and denser. This discovery turned the Big Bang from a clever idea into a well-tested scientific theory. So the Big Bang wasn't an explosion in space like a bomb going off. It was the explosion of space. In the very first moments, there was no outside for the universe to expand into. Space itself was created and began stretching. In the first few minutes, the universe was a super hot soup of fundamental particles. As it expanded and cooled, these particles came together to form the first atoms, mostly hydrogen and helium. These are the building blocks from which all the stars, planets, and galaxies would eventually form over billions of years. The story of the expanding universe is the story of our own origins. It's easy to misunderstand what scientists mean when they say the universe is expanding. It's not like galaxies are rockets flying through a pre-existing empty void. Instead, the very fabric of space-time itself is stretching. Think of it like a loaf of raisin bread rising in the oven. The raisins are the galaxies, and the dough is space. As the dough expands, all the raisins move farther apart from each other. A raisin located inside the loaf doesn't see other raisins flying away from it. It sees the dough between them expanding, carrying the other raisins along for the ride. This is a key concept from Albert Einstein's theory of general relativity. He showed that space and time are not separate things, but are woven together into a four-dimensional fabric called space-time. Massive objects like stars and galaxies create curves or dents in this fabric, which we experience as gravity. But on the largest scales, this entire fabric is not static, it's dynamic. The expansion of the universe is a property of space-time itself. It's growing everywhere, all at once. This is why we can't point to a center of the universe. From the perspective of any galaxy, all other galaxies appear to be moving away. This stretching of space has a curious effect on light. As light from a distant galaxy travels toward us, the space it is traveling through is expanding. This expansion literally stretches the light waves, making them longer. Longer wavelengths of light appear redder, a phenomenon called redshift. This is how Edwin Hubble was able to measure the speed of distant galaxies. The more redshifted a galaxy's light was, the more space had expanded while the light was in transit, which meant the galaxy was farther away and moving faster. It's the universe's own cosmic speedometer. So, are we expanding too? Is the Earth getting bigger, or you or the chair you're sitting on? The answer is no. On smaller scales, other forces overwhelm the cosmic expansion. The gravity holding our solar system together is far stronger than the gentle pull of the expanding universe. The electromagnetic forces holding atoms together in your body are stronger still. The expansion is only noticeable over vast intergalactic distances. The space between galaxies is growing, but the galaxies themselves and everything within them are held together tightly by gravity and other fundamental forces. The fact that the universe is expanding is not just a curious detail, it has profound and somewhat frightening implications for the distant future. For a long time, astronomers wondered if the expansion would ever stop. Perhaps the collective gravity of all the galaxies would be enough to slow the expansion down, halt it, and then pull everything back together in a big crunch. It would be a cosmic recycling, a universe that collapses back into a hot, dense state, perhaps to be reborn in another Big Bang. This was a comforting thought for some, a cyclical, eternal cosmos. But in the late 1990s, observations of distant supernovae exploding stars revealed something shocking. The expansion of the universe is not slowing down, it's speeding up. An unknown force, which scientists have named dark energy, seems to be pushing everything apart at an ever-increasing rate. We don't know what dark energy is, but it appears to make up nearly 70% of the entire universe. It acts like a sort of anti-gravity, a repulsive force embedded in the fabric of space-time itself. This discovery turned our understanding of the universe's fate on its head. If this acceleration continues, the future of the cosmos looks rather bleak and lonely. As galaxies are pushed apart faster and faster, they will eventually recede from us at speeds greater than the speed of light. This doesn't violate Einstein's laws because it's space itself that is expanding. The light from those galaxies will no longer be able to reach us. One by one, the galaxies we see in our night sky will disappear from view. Their light stretched into wavelengths too long to detect. Our cosmic horizon will shrink, leaving our own Milky Way galaxy an isolated island in an endless, empty void. In this far-flung future, trillions of years from now, any astronomers who might exist will look out into the night and see nothing but the stars of our own galaxy. They would have no way of knowing that other galaxies ever existed. They would not be able to discover the Big Bang or the expansion of the universe. The crucial clues would have been erased, carried away by the accelerating expansion. We live in a special, privileged moment in cosmic history, a time when we can still see the evidence of our origins and piece together the grand story of the cosmos. It's a humbling thought, a reminder to cherish the view while it lasts.